Hi, my name's Jonathan Clark, and also known as DJ Bolivia, and I'm doing a little bit of filming here tonight in Buenos Aires, in Argentina. The reason for that is because for the last couple days I've been thinking about trying to produce a series of YouTube tutorials that talk about basic audio recording techniques. Now if you look at my YouTube channel, there's already some videos out there about using various software packages. There's stuff about DJing, there's stuff about there's music videos, stuff like that. And I do want to expand on what I've already got there. I want to make it a lot more broad-based. Like I want to add a whole series of videos about actually producing dance music right from scratch, like building kick drums, bass lines, stuff like that, right up to producing different style genres like house music, drum and bass, dubstep, stuff like that. So that's something I'm also working on. Now, I'm also going to have some other videos that talk about using specific software packages in more detail, like Cubase, ProTools, Audition, Sonar, Reason, stuff like that. But tonight, what I want to do is the first video about basic audio recording. Now, I've seen a lot of musicians, amateur musicians, who are recording themselves, doing cover songs, putting it out on YouTube, and I think that's great. Like, if you want to put yourself out for the world to see, that's fantastic. But you probably want to do the best job possible. And the quality of some of the videos that I've seen is pretty poor in terms of the audio. And it's not necessarily that the person's a bad singer, it's just poor quality audio recording. So I think I can maybe help with that a little bit. So if you do want to be a professional musician someday, this video and some of the subsequent ones I'm going to make here hopefully will help you out a little bit with that. Now, if you've come here because you wanted to see a DJing video, because I do those too, that's not what this one is about, so you may not want to watch this one. But having said that, if you do want to become a well-known, well-respected DJ someday, it really helps broaden your audience if you do production work of your own, produce your own tracks, stuff like that. And although this video is not about producing dance music, it does cover some of the things that you would want to know as a dance music producer. So some of the things I cover today might actually still be relevant. So the video that I'm going to do tonight is going to be pretty simple. Basically what I'm going to do is I'm going to play a song on guitar, sing along with it, record it, and we'll go through the steps necessary to put it online. Now, most people will just use the microphone from their video camera to do this, and I'll touch on that. But I can start showing you a little bit of more advanced stuff, because eventually you may get some additional simple equipment or advanced equipment, and you might be able to start using some computer software to improve the quality of what you're doing. So I'll start to touch on that. What I'll do with this video tonight is I'll use the microphone on the video camera. I'm also going to show you the use of a basic wave recorder. I'm not going to suggest that using the wave recorder is the best long-term solution, so don't go and buy one right away. I just want to show you how they work. In future videos that I'll do over the next couple of weeks, we'll start getting into things like microphones. You might want to use a simple dynamic mic, or you might have access to a better quality condenser microphone. So I'll talk about those. Some of the other videos that I'll do as follow-ups to this, I'll cover things like using computer sound cards, external sound cards, USB sound cards, stuff like that, as a means of getting a signal into the computer for processing. I will talk about, eventually I'll talk about multi-tracking, so maybe using a sound card that has multiple inputs, and so I can use a line in from the guitar at the same time as a separate line in from a microphone. Both those signals will go into a computer and they'll record in two separate tracks, and I'll teach you how to mix that stuff, how to do effects processing on the different tracks, stuff like that, to try and make it sound a little bit better. I can also eventually cover things like multi-track recording. So you don't necessarily even need an input device that has multiple inputs. You might be able to use a simple one that has a single input and do things in layers. So you'll do your guitar as a first track, then you'll do a vocal track over top, maybe extra tracks on top of that. So I'll cover that eventually. I'll cover the use of effects. I'll cover the use of different types of equipment. I'll cover different software. But for now, tonight, let's keep it simple. We'll just play a song, we'll get it in the computer and do some basic stuff. And hopefully you learn a little bit from this. Anyway, so I've got my guitar that I'll be using. To explain the setup, I've got this camera. I'm going to be sitting right here. So this camera is going to be facing the guitar. You'll be able to see my strumming. You'll be able to see my fingering. I have a second camera, the one that's actually in my hand right now, is going to be sitting where this one is right now. And you'll be able to see me. I'm going to be singing right here, singing in through the pop filter into the Sony wave recorder. I have a pop filter. I have a Sony wave recorder. Okay, so that's how this whole thing is going to work. Okay, so two concepts that you need to learn about when you're talking about miking a vocal performer are how these things called plosives, P-L-O-S-I-V-E-S, plosives, and how sibilance affects a vocal. So that may not be that important for a simple video like we're doing today, but I may as well give you the basic background. We'll build on it in future videos. Okay, so a plosive. There's a couple consonants, consonants, that when you say them, a burst of air comes out of your mouth, particularly P's and B's. So the problem is modern microphones are really sensitive. So if I'm singing into a microphone normally, not using words that have these P's and B's and similar, the sound's not going to be too bad. But the P's and the B's, when you say these, there's a burst of air comes out of your mouth. P, B. Okay? When that air hits the microphone, because the microphones are so sensitive, it actually gets recorded by the microphone. So that causes a little bit of a problem, because when you're singing into a mic, you don't want to hear your breathing. So the way to solve this, they have these things called pop filters. Okay? So this is a pop filter. And basically, it's just fabric. It's like it's very similar to pantyhose. And so what you do is you put this filter between the microphone and your mouth, so that when you're singing, the sound carries through the nylon mesh and it goes into the microphone like normal. But these plosives, the bursts of air, the air hits the nylon, the fabric, and doesn't go through and hit the microphone. So it increases the quality of the sound that you're recording if you have a pop filter. Okay, these things are about, I don't know, $50 maybe. There is a way to circumvent this if you want to use a pop filter, but you don't want to spend $50 on one, because we are talking about basics here. What you can do is find an old pair of pantyhose, and you can get a wire frame, maybe use a coat hanger, and slide the pantyhose on over the wire frame, tape it in place, and that is a good cheap alternative to using a real pop filter. I've done that myself in the past. In emergency situations or when you're just on a budget, that works. But, for $50, if you can afford that, at least a proper pop filter comes with the screws and the mounts, clips, whatever that you need to set it in place. So, think about that too. Anyway, the thing is, when you have this pop filter, whether it's a homemade one or a professional one, you want to have it a couple inches away from the microphone. And then when you're singing into the mic, you want to be, I prefer to be as close as possible. Now, there's this thing called the proximity effect, and the closer you are to a microphone, the deeper and richer your voice sounds. So if I'm DJing in a club, and I want my voice to carry and to sound good as it's carrying, I'll put the mic right up to my mouth. In fact, I'll be talking into it like this. Okay? Now you may want to wash the microphone, obviously, at the start of the night if you're going to be doing that. But anyway, so there's this trade-off, because you want that pop filter to control the plosives, but you still want to be as close as possible to the microphone. Okay? So we're not going to worry about that too much in today's video, but I wanted you to know about, how that all works. Now there's another vocal phenomena that you should be aware of, and it's called sibilance. And that's what happens when you're pronouncing things like S's, T's, Z's, whatever, and it's that kind of hiss that comes out of your mouth. Now, the problem with sibilance is that a pop filter doesn't help. Okay? Absolutely useless. But what you can do, the easy way is to back off the mic a little bit. Most people, well, it depends on the person, it depends on the type of microphone, but if you're a good 12, 14 inches away from the mic, that'll probably solve most of your problems with sibilance. Now, of course, you can see the problem here is that, you know, to get the richer, deeper voice, the proximity effect, you want to be closer to the mic. You can't be too close because because you'll be hitting up against your pop filter or dealing with plosives. And sibilance, you need to be further away. So it really, there's no easy set rules for this. You have to experiment. Depends on the type of mic, depends on the person, figure out what sounds best. Now, you can deal with sibilance using computer software a little bit. There's these effects called de-essers. That's D-E-E-S-S-E-R. And a de-esser will get rid of some of the sibilance. If you're trying to compress a vocal to get rid of sibilance, it doesn't work. It actually has the opposite effect. It makes it a little bit more obvious. The way a de-esser works, basically, if you understand the advanced stuff, is you'll EQ that very narrow band where your sibilance is occurring, raising it up, which sounds backwards, and then when the compressor comes in and squashes everything, it'll squash that sibilance band more because it's louder, and so indirectly it gives you a better sound. The other thing is you can manually go in and edit your volumes on very narrow parts where those where the sibilance is showing through. But you know, for this video, let's ignore that for now. I just want you to know what it was about, and so we're setting up we're not even using a microphone, we're using the wave recorder, but we'll set it up so that the wave recorder is a few inches behind the pop filter, and I'll be singing into a pop filter, and yeah, let's go from there. So here I have the Sony wave recorder. It's you can see it's a pretty small portable handheld unit. It's not cheap, it's a few $100s, but it is pretty good quality. Now, I'm not going to say that this is a better approach than using a microphone. It's not. Ultimately, you're going to want to get into using microphones, preferably a condenser mic instead of a dynamic mic. But for the purpose of this particular video, here's a nice, simple, easy solution. This can be pretty useful for portable recording situations. That's one of the big benefits of this over proper miking setup. Anyway, I think I've got it set on 16-bit recording right now and 44,100 samples per second, which is kind of like CD quality. I'm pretty sure it goes up to 24-bit 96K recording. Anyway, it's not set like that right this second. You can see it's got two microphones up here at the top, left and right input, so it's got stereo miking. It also, you can attach an external mic to it if you want. Looking at the back, I've got the record level set on automatic at the moment. The high and low sensitivity of the mic I've got set on high. It's got a limiter built in, and let's see, if you've got it on manual, you can change the record level with this little knob over on the left-hand side. Takes micro SD card, whatever, for memory. It's also got some built-in memory. Anyway, it's pretty simple. Press pause and record at the same time, arms it, and you can kind of see how the input level is going in time to my voice. When you're ready to start recording, take pause off or hit play. When you're done, you can hit pause, stop it, whatever. And then this thing is going to plug in directly to the computer, just a plug-and-play device. It's got a whole lot of different menu functions and stuff like that you can play around with, but that's not really important for this video. Oh, the model. The model is a PCM M10 from Sony. Okay, so let me give you a little bit of a revelation here. I don't know how to play guitar properly. I've never had lessons, and I learned by ear, so I can do basic strumming and stuff like that. I know some basic chords, But the problem is the only two strings that I know the notes on are the two E strings, which is admittedly a little embarrassing considering my other levels of musical training. Anyway, that's a project for the next year or so, is to learn how to play guitar properly. I haven't really played much in the last 5 years, but I picked it up this past week, and I'm feeling good. I want to learn. Anyway, so the song that I'm going to play here is called Elderly Woman Behind the Counter in a Small Town. A lot of people shorten it to Elderly Woman. It's by Pearl Jam. A lot of people don't know the name of the song. They think it's called Hearts and Thoughts, but that's not correct. Now the song's quite easy. That's why I picked it. It's got 3 chords. D, C9, and a G. That's it. Those are the only 3 chords in the song if you play it properly. Now I don't quite play it properly because there's 2 sections in the song where it's supposed to go down from the C9 to the G, and what I've done, which I think sounds better, is instead of going from that C9 down, I'm going from a C9 and sliding up to a D9. The only problem is there's 2 strings you don't want them to ring. The bass string, unless you're good enough to thumb that, what you should do is just make sure thumb's touching it to mute it. And the same thing with this string, which is the G string. You want to I call it slurring my finger. You want to slur your finger, that one, up against it so that doesn't ring. So basically there's only 4 strings that are playing for that chord. So, okay, you'll see it when I play the song. It's not quite the right way to play it, but if there was a bass guitar accompanying and that bass went down to the G, I think it would sound really awesome. So we might experiment with that in a later video, I don't know. Anyway, so it's just very simple. That's how the song goes. Anyway, you can watch it when I play it here in a few minutes. Pearl Jam, check it out. Oh, and because I'm not a singer at all. I'm a worse singer than guitar player. The key it's in, D, is too low for my voice right now. So what I'm going to do is use this thing called a capo, and I'm going to put it here, and effectively, if you've never seen one of these before, instead of this being the end of the strings, this is, so I've gone up 2 semitones. So if I play the same sort of pattern with the chords here, then it's still a chord. I'm using what people would call a D chord, but because my notes are all a full tone higher, it's actually an E chord. So I'm kind of playing E, D9, and A. And then of course that D9, which looks like a C9, when I slide up will become an E9, which looks like a D9. A little confusing, yes, but easier on my voice. There's a couple sections in the song where actually your voice is supposed to raise quite a bit too. I'm probably not going to attempt that tonight. Anyway, that's basically how the song goes. So before I actually do the recording of the song, I want to talk quickly about some of the different types of effects that I would typically consider putting on a vocal. Basically, I'd be looking at possible reverb, possible delay, possible chorus or vocal doubling, which are sort of separate things, sort of the same thing, depending on how you do it, or EQing. Okay? Now in this video, we're not going to get into all of those, but I may as well explain to you very quickly what I'm talking about so you've got a better idea for future videos, some of the stuff that we'll get into. Okay, EQing, equalization, is adjusting the pitches up or down of various pitches within the audio spectrum. Okay, I will get into that later in this video. A second thing is digital delay. And digital delay is basically when you take the sound that you've recorded and a second version of it gets played shortly after the original at a lower volume. Okay, so if you had something like a gunshot and you had a delay of, say, a quarter of a second, and the second one was at half the volume, the way you've set the parameters, you might get that bang, bang. Okay, and so when that's used in rhythmic music, it can sound pretty cool. Now, we're not usually talking about really long delays like a quarter of a second. Sometimes we're talking about a few thousandths of a second or milliseconds. Okay, so delay, that's basically how that works. We're not going to get into that in detail on this video. The next thing, chorus or vocal doubling. The reason I say they're kind of two different things is the way that I like to try to teach it is with a chorus, you might take a single vocal recording and you process it using the computer, and the computer generates very close versions of that, but slightly different than the original, and it overlays them. So if you had, say, a 3-voice chorus that you created with a computer, that single vocal track that you started out with, the computer's going to make 2 copies. It's going to make each one just very slightly different by adjusting pitches and timing within it, and then it'll play all 3 of them together. So basically it sounds like instead of one lead singer, you've got 3 versions of the lead singer all singing at the same time, and their voices are really close, but you can hear basically that there are different voices. Okay, vocal doubling is the same sort of concept, but usually the way I look at it is that you take a vocalist, she or he sings a line, and then you record them a second time singing the same thing, and they're trying to make sure the timing matches of both of these, and you take the 2 different versions of their vocal takes and you play them together at the same time. So it kind of gives you the same sort of effect as a chorus, but it's usually a little bit different. Anyway, we're not going to get into that in practice in this particular video, but again, wanted you to know what that is. So we've talked about EQing, delay, vocal doubling or chorus, and reverb. Now reverb is something that, again, we're not going to try applying reverb in this video, but this one is a little bit relevant to this video because we're recording in a bathroom. Now, reverb, basically what it is, reverberation, it's kind of it's the persistence of sound in a space after the original sound is produced. Okay, so let's say that you sing a note. If you're in a small enough space, well, even a concert hall can have this effect, but no matter what, as you sing, that sound spreads out, the sound waves spread out, and as they hit different parts of the room, if the room has reflective surfaces, acoustically reflective surfaces, then parts of that sound wave are going to bounce back and bounce around the room. So if you've got a microphone on stage in front of a singer, a lot of the noise that the microphone is going to record is going to be that singer's actual voice. You know, as the sound takes a very, very brief time, and it takes it takes a fraction of a second, and it goes directly to the microphone, so the microphone records that. But sound waves go out in all directions, so not only do you have the sound waves going straight from the singer's mouth to the microphone, you have copies of those waves that are floating around, they're shooting through the room, they're hitting walls, they're hitting ceilings, floors. Some of them will bounce back and they'll come back to the microphone, and the microphone is going to pick up that reflection, obviously at a fainter volume. But the strange thing is, well, I mean, you're going to get different types of reflections in any given room because it depends on what material is on the wall. If you have something like tile is very acoustically reflective, so sound waves bounce off it quite clearly. If you have something like foam or carpet, there's a lot less reflection. And of course it also depends on which direction the wall is facing, because it's like a stone skipping in water. If you can imagine you've got a flat stone and you throw it at the surface of a lake, it hits the surface and sometimes it bounces off, and the angle at which it starts to bounce off is roughly the same as the angle at which it hit. Perhaps a better example would be light hitting a mirror. The angle of incidence is exactly equal to the angle of reflection. That's what those angles are called. So anyway, if you've got a singer and there's a wall beside them, sound coming from the singer hitting that wall is mostly going to bounce away. But that would be like, if you can imagine someone sitting on stage, that would be what you're getting off the side walls. But when you look at the back wall, if that back wall is perpendicular or facing the singer, then a lot of the sound waves that go and hit that wall are going to come straight back at the singer. Okay? And then some of the sound waves that are hitting the side walls will hit the back wall and then come back and hit the microphone on stage. So you've got all these waves going off in all these different directions. So if you could actually measure what's hitting the microphone, you've got the very obvious original wave coming straight from the singer's mouth to the microphone. And then you have all these different reflections that are coming in at different time intervals, very, very short time intervals, but different intervals, and at different volumes because sound fades as it travels. Okay, so it's this massive group of smaller, quieter reflections coming back and hitting the mic later after the original sound hits it. That is what's called the reverb, the reverberation. So there are several different ways to emulate reverb on a computer. You can have effects which basically recreate reverb, and there's different types. There's plate reverb, there's spring reverb, there's convolution reverb, there's stuff that's mathematically modeled reverb, there's stuff that's based on actual measurement samples. I don't want to get into that in too much detail, but let's just say there's a lot of different types of reverb that can be done on a computer. But in the right circumstances, you can also get reverb just by physically recording what's happening in the room. Now, if you were outside in an open space, you're not going to get any reverb, really, because if it's wide open around you, all those sound signals that are shooting off to the sides, to the front, above, down, whatever, essentially none of those are going to come back. That's not completely true, because a very small number will come back. Like, for instance, the ones hitting the ground will come back up. But essentially, no reverb in an outside, wide open space. In a very, very large building, unless the walls are highly reflective, you're going to get very little reverb because the sound's traveling so far before it hits walls and ceilings and stuff like that. And if those walls are made of anything that dampens the sound or absorbs the sound, then there's going to be very little energy bouncing around to eventually come back. So a huge hall with acoustically dampened walls, whether on purpose or accidentally, you're not going to get much reverb. If you're in a large hall with very reflective surfaces, then yes, you're going to get a little bit more reverb than in a hall that doesn't have those reflective surfaces. As the room gets smaller, you're more and more likely to get reverb that can be measured, that the microphone can pick up, because the sound doesn't have to travel that far to a wall and to reflect back, which means it loses less energy before the time it gets back to the microphone. So the smaller the room, the more obvious the reverb. When you pair the size of the room with the type of surfaces, whether they're reflective or absorptive, that really determines the ultimate strength of the reverb. So small room plus highly reflective surfaces, you'll get tons of reverb. And that's exactly what is the case in most bathrooms, washrooms. Even if you don't have tile walls in your bathroom, just that kind of small room, like a laundry room, bathroom, whatever, you'll get a lot of natural reverb when you're recording. So reverb usually makes a voice or instrument sound better. Now, there can be too much. So, for example, if you've got a singer and they're trying to pronounce a lot of words, short words like dog, I don't know, what's a better example would be words that sound the same. Saw, sand, sat. okay? If you've got a ton of reflections, acoustic reflections coming back, and they're hitting the microphone before the end of the word, then some of those are going to muffle slightly the sound. They're going to muffle the singer's voice, whatever. The end of the word is being muffled by reflections from the earliest parts of the word. So with vocals, reverb can sometimes be too much because it makes the sound muddy. It's harder to tell what the singer's singing. If you've got an instrumental sort of piece of music or something like that, maybe it's not so bad. But it totally depends on what you're recording. So anyway, with reverb, like I say, too much can be a bad thing. And in the tile bathroom that I'm recording here, it is too much. Now, I find personally that when you hear reverb live, it can really make something sound better. So for me, playing the guitar, singing, and hearing the reverb of the natural reverb of the guitar and of my own voice, it sounds a lot better to me than if I was sitting out in a wide living room or outside. But it can be too much, and the microphones tend to pick that up. Now I'm using 3 different microphones realistically in this recording space because I'm using, I've got 2 cameras. I've got the low camera by the guitar, I've got the high camera facing my face, and I've got the wave recorder, which should be the best signal, the best recording of the 3. Okay, and so what I'm going to do at the end, once we start playing with this stuff, I'm going to show you the difference in audio quality between all 3 files. And you're going to hear some reverb on all 3 of them, obviously. But I think with the 2 cameras, because the cameras aren't as close to my voice, you're going to hear a lot more reverb. And the reason for that is with the voice recorder, there's such a small interval between the time I sing and that sound directly hitting the wave recorder that I have a louder voice relatively hitting the wave recorder, and the reflections coming back hitting the wave recorder are going to be lower relative to my voice. Okay, with the 2 cameras, the cameras aren't going to be 8 inches away from my mouth. The worst camera is going to be the one down by the guitar, because that's a good 4 feet away from my mouth. And so my voice is fading as it gets closer to that lower camera, and the reflections off the walls hitting the camera are not any softer than the ones that are hitting the wave recorder. So relatively speaking, that lower camera is going to be getting more of the reflections and less of my direct voice. And with too much reverb, it makes things sound muddy. Okay? So you're going to hear a muddier sound on that lower camera. The upper camera is going to be kind of medium muddy, and then the wave recorder is going to have the least amount of reverb. Now, in an ideal studio situation, what many people would probably want to do is they would want to record in a slightly bigger room and not use so much natural reverb. They'll want a dry signal that's cleaner, and they'll put the right amount of reverb on with a computer. Because you can always add reverb to a sound after it's been recorded by using the effects on the computer. But you can never take away reverb if you have too much. There are ways to kind of mitigate the amount of reverb, but it's not a great approach. I'll try and show you this a little bit later. Okay, so normally, yeah, we would not want to use so much natural reverb, but I'm recording in this bathroom this time. You're going to hear you're going to hear a lot of natural reverb, and it's it's good for educational purposes for this video. The other reason I'm using the bathroom, by the way, is because it's kind of insulated, so there won't be as much outside noise. Anyway, so reverb is going to be happening naturally on our recording. We're not going to touch on delay. We're not going to try adding any vocal doubling. We will be doing some EQing, so that's going to be the main focus once we've got this recording. So let me go play the song, and what I'm going to do is I'm going to play the song, and I'm going to use the audio from the upper camera, I believe. and that audio is what you're going to hear this first playthrough. We're going to then go into some software. We're going to use Audacity this time because it's free, and we're going to extract the audio from both cameras and from the wave recorder. So I got 3 different versions of the same thing that I've recorded, and we're going to play with each of these and see what kind of different sound we've got out of the different recording devices, figure out which one's going to sound best. We're going to play with it with a bit of equalization, and then we're going to use that as our final version of the audio. Yeah, and by the way, all these different files that I'm going to be playing with, I'm going to put them all into a zip folder that you can download. If you look in the description underneath the video on YouTube, there'll be a download link for that. So if you actually want to download these files and play with them on your computer to get a better sense of what I've done, then go right ahead. Okay, but for now, let me go play this song. Okay, so now that the recording is done, we need to make sure that the files are on the computer so you can play with them. So I'm going to assume that you know how to do this, but just in case, basically with this Sony wave recorder, you plug it in, the other end goes into the USB port on the computer. I turn it on, And as I turn it on, you can see that the PCM recorder has just shown up here on the in Windows Explorer, and similar for Mac, I'm sure. Anyway, open it up, dig down, and essentially you'll see a folder there eventually, and you can see I've got some different files already there on the wave recorder. Okay, I'm going to actually turn that off again right now because I've already dumped these. So I look here onto my data drive. I've got a folder called Elderly Woman, and you can see that I have two camera recordings, Elderly Woman lower camera and upper camera, and I've already brought the audio in from the wave recorder and renamed it, so that's this audio. Okay, but the problem is when I go into a program like Audacity or some of the other audio editors, they don't like video. They want to work with audio. So what we're going to do is we're going to convert these two video files. Well, we're not going to convert them. We're going to extract the audio as a separate file that we can play with. Okay, now I find one of the easiest ways to do this is go to a let's close some of these things that are going to show up. We're going to go to a program called VLC. VLC. So I search for VLC, and where is it? There it is. Okay, so VLC Media Player. So this is a free program. It's available on the Mac, and it's also available on Windows. Okay, so if you don't have it already, download it onto your computer. Okay, install it, and we'll go from there. Now you can see down here, down by my quick launch bar, I've already got VLC installed, so I'm going to open it up. Okay, now here are the steps to extract the audio. It's supposed to be fairly simple. It's not entirely simple, to be honest. I got a little annoyed when I was trying to make this work earlier, and for some reason I couldn't extract a WAV file properly. It wasn't working. So I haven't figured that out yet, and I don't want to take the time to do that right this second, because normally that's not something I do very often. So what we're going to do is we'll go a different route. We're going to go into Media, we're going to go to Convert Save. Okay, we're going to, it says File, you can select local files. So I'm going to go into my directory, I'm actually in it already, and let's do the lower camera first. So I'm going to double click on that. This is the video file that we're going to convert. We're going to go down to the Convert Save thing here. There's a drop down menu, choose Convert. Okay, for source file, you can see it's already put it up there. For destination file, we're going to browse and make sure that we're in the proper same directory that we were using. Okay, and we're going to call the output file audio from lower camera. And we're going to save this as a FLAC file, .flac. Okay, FLAC is a fairly high quality audio type file. It's called a lossless because it doesn't compress to a lower audio quality like an MP3 does. Okay, so there I've got the audio file typed in, .flac. For the settings, profile, what we're going to do is hit this drop down menu. We're going to go down to the FLAC option, audio-FLAC. We're going to go into this tool icon, edit selected profile, click it. Okay, we're going to, for an encapsulation method, we're going to keep it on raw. For video codec, if this was already checked, you're going to uncheck it because we don't want video, we're just looking at audio. For audio codec, yes, the audio has to be turned on. We do not want keep original audio track. In this drop down menu, you've got a whole bunch of different choices, and I was saying the wave should work earlier. I don't know why it didn't, but anyway, make sure you're on FLAC. For bitrate, whatever it happens to be on, let's put it on a fairly high bitrate, so we'll start with 512. Sample rate, 44.1 is the sample rate that CDs use, so that's fairly high quality audio. Now, again, if in some of the later videos that we do here, once we're getting into good microphones and stuff like that, we're going to start working with a lot higher quality projects. but for today we'll just go with a FLAC audio. So subtitles, we don't need subtitles turned on. So all these settings are good. We'll save that. And what we're going to do is we're going to hit start and see what happens. Make sure interlace, dump raw input, those aren't checked. Okay. So start, boom. And if you go back into this, you can see my file is playing very, very quickly. And what it's actually doing, it's not playing it over the speakers, it's converting this at this very moment. Now you can see up at this end, it's a fairly long video file, it's 12 minutes. Only about 4 minutes of this file is the audio that we want, that we're going to be playing with, but we'll cut those 4 minutes out in a few minutes. Okay, so this is almost done and finished. Okay, and I can see audio from lower camera dot FLAC. Okay, so that's the file that we just created. Now we also want the audio from the upper camera. Okay, so let's go back into VLC. Let's do this one more time. But you know what? I had this set at 117% volume. It's possible, I don't know this right now, but it's possible that that will increase or amplify the volume level of the audio as it converts it from the video to audio. So I probably should set that back to 100. I probably should redo the first one that I did just a moment ago. I'm not going to bother because it's lower camera audio and it's not going to be critical at the end of this video. But I'm kind of curious to see what will happen. So anyway, so make sure your volume set at 100%. And once again, we're going to go to Convert Save. We're going to use the upper camera recording. Now they're both in there, so let's remove that one. So upper camera recording is good. We're going to go to Convert Save once again. We're going to go with our destination file is upper audio from upper camera.flac. Save, so that's got the right file name there. Those are all unchecked. Again, we're going to go down to FLAC. We're going to double check that we're on RAW. Video is not enabled. Audio codec is FLAC. Subtitles off, so that's all good. Those are unchecked, so let's start once again. And once again, you can see that the audio is streaming, being converted. Sorry, not streaming. This program, VLC, actually has an audio or a setting on it. You can see when I use that Convert Save drop-down menu, one of the options was Stream. And this program lets you actually stream video directly to the internet so other people can watch. So I think that would be like a YouTube channel where you want to do a live show or something like that. Or you could broadcast a recording, but you can hook your video camera up to the computer, and then the signal that's coming in live to the video camera can go into VLC, and then rebroadcast as a stream to the internet. Anyway, we're not doing that today. So our file is converted. We have audio from upper camera, audio from lower camera. Perfect. Let's close VLC. We don't need that anymore. Now, let's go into Audacity. Audacity is the program we're going to be using. So, we'll do a search, Audacity, and there it is right at the top of the search options. So this program, again, free program for Windows or Mac users. If you don't have it already, download, install it. Okay, now I do have it. You can see it right there on my quick launch bar. So let's open that up. Now let's go in and open those two FLAC files. Let's start with the lower camera. Open it. Okay, there it is. Now this section of audio here at the end is actually the only part that I want. So I'm going to highlight this part. I'm going to delete it. And then that leaves me just the section that I do want. And I'm going to resave this as export. I'm going to export this as a wave file. There we go. And we're going to put it into our folder. Now it's audio from lower camera. Perfect. Okay, so that's been exported. I'm going to hit Control W, which closes. Don't need to save changes. And let's load the other one. Let's load the audio from upper camera as a FLAC. Same thing, we don't need all this stuff at the beginning. And I'm going to... you know what I forgot to do? I forgot to highlight. So I'm not sure what happened with that first one. When I exported, since nothing was highlighted, we might not have gotten any noise. Let's find out. Oh no, we're good. Okay, on some audio programs you might want to hit Control A to highlight everything, or you might want to drag your mouse across to highlight everything. Anyway, once again, with the audio from the upper camera, export audio from upper camera as a wave, save. I'm not gonna play with the metadata. Okay, and once again Control W closes. Okay, so right now, if I go back into our directory, we have our audio from lower camera as a FLAC file and as a wave file. This one is going to be the full 12 minutes that we extracted from our video file. This one's going to be the shorter version, just the 4 minutes of stuff that we need. And as far as the audio from the upper camera goes, same thing. We've got our 12-minute long FLAC, and we've got our shorter version from the upper camera, the 4 minutes of good stuff, as a wave file. Okay, so now our next step is we're going to use Audacity. We're going to reopen those wave files, and let's start playing them with them and see what we can do to make them sound a little better. Okay, so now what we've done is we've taken some video files and we've extracted the audio. Now the reason this is useful is a lot of you, if you want to play with audio recording and you think, I need to go out and buy a microphone, you may not need to spend the money, because as you've just seen, you can take a video camera file and just extract the audio from it. Now, a lot of people these days do seem to have high-def video cameras. And if you've got a high-def video camera, it's probably got a decent microphone on it, so you might be able to use that for basic audio recording. So for example, once you learn how to do session files and stuff like that, you might get to the point where you record your guitar playing by putting the microphone on a tripod, your camera on a tripod, say 3 feet in front of you in a nice quiet room, and you'll play that, you'll extract the audio, you'll move that audio file into one of the tracks of your session, and you'll go and next you'll want to record a voice layer. And so you'll have the camera back in front of you again, this time perhaps a little bit higher, more level with your voice, and you'll play that guitar back through your headphones. You'll be able to hear what's been going on, and then you'll sing into the video camera. And you'll extract that layer of audio and bring that in as a separate second track in your project file or your session file within your audio editor, and you'll be able to edit each of those as separate entities. Okay, but anyway, for now, let's move on and let's see what we have. So far, we have okay, so we have the audio from the lower camera, we have the audio from the Sony recorder, and we have the audio from the upper camera. Let's just listen to 10 or 15 seconds of each one and see what the relative sound quality of each is. And remember that we're in a small room with a lot of reverb, tile walls, and so it's going to sound what I call muddy. And the camera that's down low beside the guitar should have a lot of that thick lower frequency guitar sound, quite muddy. And okay, well, let's just try. Equalizer's off. Okay, so you can hear that the guitar is very upfront there. The vocals are a lot quieter relatively, and there's a ton of echo going on that you should be able to hear. I hope that's obvious. Ton of reverb going on. Okay, so let's close that. Let's try the upper camera, and this one should have relatively more vocals, but it'll still be a lot of reverb. Okay, definitely more vocals there, and because the vocals are higher in pitch than the guitar, it's more of a trebly sound from this thing. Okay, and then finally let's listen to our audio from the Sony recorder. Now that's a cleaner sound. I like that so far. We're not hearing as much reverb for some reason. We are hearing the vocals quite clearly. I mean, there's still obviously quite a bit of reverb there, but it's not quite as overpowering as with the camera microphones. Now, what I want to do next, I guess I should really talk to you about equalization and the frequency spectrum of audio. Okay? Sound basically is a type of energy. And a sound wave, let's say something makes a noise, bang. Those sound waves travel outward from the source of the noise. They go pretty fast. I think they're a little over 1,000 feet per second. That's nowhere near as fast as the speed of light. Light is like 186,000 miles per second, and so light's far, far faster than sound, the way it travels. But they're basically the same sort of thing. They both have a frequency. Sound that is audible to the human ear has frequencies of between roughly 20 hertz and 20,000 hertz. You look at the frequency of light, and it's in the many, I think, billions or trillions of hertz, much faster oscillations in frequency. But so for sound, okay, I just said the human ear has a rough audible range for sound from 20 hertz to 20,000 hertz. Okay, so a hertz, it's a unit of measurement for sound, and it measures frequency in cycles per second, in vibrations per second. Okay? So a very deep sounding sound, something with a very low pitch, would have a small number of vibrations per second. So the very deepest sounds that you can hear, like the rumble of a waterfall, rumble of a train in the distance, like those sort of low pitched things are going to have very small frequencies, like 20 to say maybe 100 oscillations per second, or 20 to 100 hertz. As you start moving up through the frequency spectrum, things that are higher in pitch will have higher frequencies. Okay, so you look at something like a noise that a singer can make. Okay, maybe they can hit a note that's around 1,000 hertz. Okay, so that's sort of getting more up towards the middle of the audible spectrum. Then you go higher and higher and higher, and you start hearing really high-pitched noises like a bird whistle or something even higher than that. And you're going to be up into a couple thousand hertz. Okay, and the very highest sounds that people can hear, say 20,000 hertz, or you use the prefix kilo, so 20 kilohertz, That's kind of the upper range for a human ear, and that's for somebody who's who has good hearing. As people get older, that range, that upper range, usually will start dropping to maybe 15,000 kilohertz by the time you're quite old. Okay, but anyway, for an audio engineer, we usually concern ourselves with, say, 20 to 20 kilohertz as being the range that we want to play with. Okay, now there are sounds that are lower than 20 hertz. Most people can't hear them. So if we have a song, sometimes what we'll want to do is filter out, eliminate all the frequency range below 20 hertz, because no one's going to hear them anyway. So basically we're just getting rid of the sonic energy below 20 hertz. We can do the same thing at the upper end of the spectrum. If there's all kinds of sounds that are out there at more than 20 kilohertz, very few people can hear them. You know, some people have good hearing and they might be able to hear stuff around 21, 22 kilohertz, but for most of us, it's not possible. And in fact, a lot of the stuff above 16 kilohertz, most people don't really hear it or just barely hear it at all. So an audio engineer, when they're mastering or playing with an audio file, they may get rid of all that really upper energy because it's useless if most people can't hear it. Okay? So equalization is something that you want to learn about, because you've got all these different frequencies from the very lowest to the very highest, and some of them sound better than others. So what you do with equalization is you're adjusting the amplitude of different frequencies. And so by adjusting the amplitude, I mean if there's a certain frequency that you want to bring out, you want it louder, then you amplify it, or you increase the amount of that frequency. And if there's a certain frequency you don't want, you'll decrease the amplification to lower the volume of that sound. The more amplitude, the louder it's perceived by the human ear. Okay, so with an equalizer, either as a standalone unit that you can process stuff with, or as what we call it as a plug-in, as an effect within a computer program, what we're going to do is we're going to raise and lower different frequencies across the audible human spectrum, and we're going to try and make our music sound better by changing some of these frequencies. Okay, so if you go onto the internet, I mean, this whole subject of equalization is something that you should study, not from just what I'm telling you. Go out and spend a day or two and read up as much as you can about sound and about equalization and about frequency spectrums, because this is stuff that you've got to know as a musician, one of the very important things. I mean, what I'm going to tell you today, you can kind of squeak by, probably, hopefully, with what I tell you, but you certainly, if you want to learn more, this is stuff that I've studied, you know, for weeks and weeks as someone who studied music and sound, and but you can find this stuff on the internet. Go out and study it. Anyway, if you go on to, let's say we're going to Google something like audio frequency spectrum. Okay, and I'm going to go into images, and I'm going to, let's look for some that are larger than that. Okay, so we've got something that's a little bit higher quality. Audio frequency graph. Let's try that. Okay, let's look at this particular graph. Okay, full-size image. Now, okay, this is perfect. This frequency response chart shows from 20 kilohertz, 50 kilohertz, 20 hertz, 50 hertz, 100 hertz, right up to 1,000 hertz or 1 kilohertz, and then goes right up to 20 kilohertz, 20,000 hertz. Okay, so this kind of covers the range of human hearing. And this particular chart, it shows a piano keyboard And you can see the lowest notes, which are on the left side of a piano keyboard, have a very low frequency. They're probably around 30 hertz. You get up around middle C. This is middle C on a keyboard if you're used to playing a piano. And the frequency of middle C, I think, is around 261 hertz, which kind of makes sense. You go up to the highest notes on a piano, on the right side of the piano, highest pitch, and you're up around 4,000 hertz or 4 kilohertz. But of course there's sounds that are higher than the higher notes of a piano. Now you'll also have to look, this frequency response chart, and almost every chart you'll see, it's on what's called a logarithmic scale. And so what that means is, if you had a linear scale, everything from 20 to 20,000 is going to be in equal interviews as you go left to right across the chart. But with a logarithmic scale, you can see that as you go higher, the distance between frequencies decreases. So on the left side, see you have this huge gap, that's an inch of your chart, and the only difference is a range of 30 hertz. But you go over here, and an inch on this side of the chart is a huge range. It's 5,000 hertz difference, from 5K to 10 kilohertz. Okay? And that's just because the logarithmic nature of music makes it that way. If you know anything about pitch of notes, and I assume if you know, I hate to be dumbing this down. I'm assuming if you know how to play a guitar or piano, you kind of know some of this stuff anyway, but I'll touch on it. So on a piano keyboard or on a guitar, as you go up one octave from one note to the same note an octave higher, your pitch doubles. Okay, so if middle C is actually around 261 hertz, then the C, which is an octave above middle C, will be double 261, or it'll be about 522 hertz. Okay, go up another C, it doubles again to around 1044 hertz. So that's how the whole thing works. Anyway, you look down here and you can see a guitar, the range of a guitar from the very lowest note, say the low E string is probably that note, that's down around maybe 80 hertz. The highest notes on a guitar, which would be when you're very close to your to the body of the guitar on the highest string, those notes are up around 1400 hertz. If you look at a note that you would be playing, like say I play a D chord on the guitar, the highest note on the D chord on that top E string is an F sharp. And I think that F sharp would be the one that's just above middle C. So you look at the frequency of that, and you're looking at, say, around 400 hertz for that note. Okay? So that means that your guitar notes, when you're playing chords on a guitar, you're not soloing way up towards the body of the guitar. The notes on your chords are going to range from frequencies of around 80 hertz up to, say, about 400, 450 hertz. Okay? For a singer, their notes are usually higher than the guitar notes. Not always. If you've got a male singer with a low vocal range, say a baritone or a bass range, then their notes might overlap most of the low notes that you're playing with guitar chords. But if you get someone with a higher vocal range, like say an alto, okay, if you've got someone with the alto range, that's the range. You can see it's called contralto for a female usually, and if it's a male in the alto range, it's usually called a countertenor. So anyway, that's the range. I think that's the range that I am. A countertenor range would range from the G note below a middle C on a piano to about a little bit above the C, that's a full octave above middle C. Okay, my range is roughly there, a little bit below middle C to about an octave above middle C. Okay, so that range of pitches where I'm singing is above guitar notes. Now, I'll have to point out that when you're talking about these notes, you're talking about the main frequency that they come through, okay? So if I hit a note on a piano, the main frequency that I hear, that's what the pitch of the note is called. And that's called the fundamental frequency, the main frequency, okay? But the interesting thing is that there are harmonics associated when someone sings or someone plays a note on a guitar or a piano, whatever. And the harmonics, I think the easiest way to explain them is they are fainter copies of the fundamental frequency, but at different pitches. And they're usually at multiples of the fundamental frequency. Okay? So if you're singing a note that is a middle C at 261 Hertz, then you're probably going to hear harmonics at multiples of that 261. So you're going to hear a fainter pitch within that voice at double, or 522 Hertz. At triple the fundamental frequency, or at quadruple the fundamental frequency, you're going to hear a little bit of those notes coming through also. And so the main note, the fundamental, plus the smaller, the quieter harmonics that are above it, is what gives you your sound. So if I played a single note on the keyboard, and I am looking at this in a computer software program, and I've got some sort of frequency analyzer, spectrum analyzer, then I'm going to see a peak on the graph where that fundamental frequency is. But I'm also going to see pitches above that, harmonics, which also have a little bit of energy. Okay, let's move on. I can talk about the frequency spectrum and all this stuff until I'm blue in the face, but you can also look this up on the internet and learn it that way, which I suggest you do. Let's put some examples into practice. Now, with Audacity, although Audacity was my focus for this particular video because it's a free software program, Audacity is not a good program, in my opinion, for doing live, real-time previewing of when you're playing around with the audio spectrum, with equalization. So I'm going to jump in and temporarily use a program from Adobe called Audition. It started out as Cool Edit Pro about 10 or 11 years ago, and eventually Adobe bought it and changed the name and upgraded it quite significantly. Okay, so we're going to use Audition to figure out how we are going to equalize our file. And then we are going to go back into Audacity and actually do the equalization with Audacity just to prove that it can be done. Okay, so we've already determined that the cleanest recording that we have is actually from the Sony Wave Recorder. So let's open that. Okay. Okay, I'm going to highlight it by hitting Control A, highlight the entire file, and I'm going into I'm going to go into Effects, and I'm going to go into Filter and Equalization. And okay, there's a couple different types of equalizers out there. There's what's called a graphic equalizer, okay? And this is probably the type of equalizer that a lot of people are used to seeing, and it's the one that if it was a physical piece of equipment, it has all these levers, levers, and each lever controls one band, one frequency band. And so what you can do is you can move things up and down with this. We're going to come back to that. A graphic equalizer is a good thing. There's another type called a parametric equalizer. Okay, and this one instead is what we're going to use for determining how we're going to shape the frequency of the different frequencies within this audio file. Okay, so with a parametric equalizer, instead of being restricted to specific bands that you are restricted to with the graphic equalizer, instead you can pick points. And with each point, you can set three things differently. First of all, you can set the frequency. So looking at point 2 here, we're at 199 hertz now. So you can move that to the left and right. Okay? So you can see I'm moving my point to different areas. Second thing you can change is your gain, and that determines how much the gain is amplified or how much the amplification is decreased. So flat means zero amplification. Anything below means a lower volume because you're decreasing amplification. Anything above zero is raising the volume, increased amplification. The final of the three settings on each of these is the Q value. And the Q value is basically the width. And so right now you can see that it slopes up so that you have a gradual increase of all the frequencies beside your target frequency, and then another gradual decrease as you go higher in frequency away. So if I change this Q value, what's going to happen is it's going to narrow, oops, let's try changing the right one. It's going to narrow the width of the band that we're trying to change. Okay? So you can go from a fairly wide increase to a very specific narrow increase in frequency. Okay, so on this particular thing they all default starting out at 2. Alright, so the nice thing about Audition is that it lets you preview as you're playing. Okay, so what I'm going to do is I'm going to let that play, and I'm going to make some adjustments here. Okay, first thing that I want to do is I want to get rid of the lower frequencies, because remember how I said that anything below 20 hertz none of us can probably hear, or very few of us can hear, but even the stuff just above 20 hertz sloping up towards 50 or 60 or 80, even that stuff can be reduced a little because most people don't hear it. It's low energy, it's kind of a rumble, it's not really good sounding audio. So the way I can do that is I'm going to put a high pass thing on here, and basically high pass means only the higher frequencies get passed. Now let's see if we can hear a big difference. So hopefully you can hear that with the camera. When I come down here and have this set around 50, it doesn't really seem to make a huge difference compared to nothing at all. But on a good stereo system, it would get rid of some of that really low rumble. I'd be able to hear it. And more importantly, it gets rid of some of the energy in the low end. If we don't need it, let's not have it there. And at some point when I'm talking about MP3s and stuff like that, I might go into that in a little bit more detail. But basically, the high pass, I'm only letting the stuff above, say, the 30 to 50 range really come out at normal intensity. And I'm going to do the same thing up at the top end. I'm going to put a low pass filter in, which means only the lower frequencies pass. Okay, so if I turn this on, and I'm going to increase the sharpness of it. Remember how I said about from 15,000 on up, not as many people can hear that stuff? So we've got our frequency set to around 15,000 there, and stuff above it, you've got a roll off, it's called, and some of the high frequencies are wiped out. Doesn't really sound like it makes a big difference, but it does. Okay, so next thing I'm going to do is I want to play with the different areas within this audio file. So I'm just going to let this play for about a minute or so, and I'm going to raise and lower some of my points on this parametric equalizer and see if I can get something that sounds a bit better to me. It's hard when you're stuck upon the shelf. I change by not changing at all. It's my town predicts my fate. Perhaps that's what no one wants to see. I just wanna scream hello. My God, it's been so long, never dreamed you'd return. But now here you are, and here I am. Hearts and thoughts fade away. Hearts and thoughts they fade away. Hearts and thoughts they fade away. Hearts and thoughts they fade always. Hearts and thoughts they fade away. Hearts and thoughts they fade away. I swear I recognize your breath. Memories, fingerprints are slowly erasing. Me you wouldn't call, 'cause I'm not my form. It's hard when you're stuck upon the shelf. I change by not changing. Okay, if I turn this button, toggle this off, it'll go back to the original without any equalization. Perhaps that's what no one wants to see. I just wanna scream. Okay, so that's kind of muddy sounding. Turn the EQ on. Sounds better. Okay, so basically what I've done is, I'm going to write this down. I've cut off the stuff below 50 Hertz completely, as much as I can. I've got a bit of a drop just below 100. And I have a small peak around 150 in that curved valley section. Then going way up around 4K, I've got a slight increase, and up around 11K, I've got a slight increase, and then above 15 kilohertz, I've got it tapering off again. Now, something you should know, cardinal rule, extremely, extremely important, is with equalization, you're going to do a better job. Instead of raising stuff up above the target level, you want to drop stuff out. Okay? So instead of taking everything at 0 and having peaks all over the place at frequencies you like, instead you keep those peaks at 0 and you drop other stuff away. Sounds much better. Now, you can have slight peaks. You can see I've done that in this particular thing. My points number 4 and 5 are both slightly above the 0 decibel. But the only way you can really get away with those is if you have a lot more that's cut below the 0 decibel level. So you can see my high frequencies above 15,000 up here are down below the 0 axis. All the stuff down here, see, look, there's this big chunk of stuff in here that's all been cut out by my equalizing. So the amount of area, I guess you could look at it that way, the amount of stuff I've cut out in this big area is definitely a lot bigger than the small amount of stuff that I've increased in the upper areas. Okay, so I've got a rough idea where I want to play with my frequencies. Let's close this. Let's get out of here. We'll go into Audacity. We'll open our file, and that's going to be the audio from the Sony recorder. Okay, now within Audacity, I want to, let's drag this down first of all, because that way you can see your left and right channels better. Secondly, I don't like the way that the volume is displayed on this timeline. If you click this drop down menu, right now it's on waveform view, and that's why that's grayed out, because you can't click on it to change it to waveform view, it's already there. But I want to go into waveform decibel, so let's click on that. And then this is the type of view that you'll see in most audio editors. Okay, the other thing I'm going to do is I'm just going to drop out one of the two channels so I got a really much better idea of the rest of it. Okay, the other channel's still there. I'm still working with it, but just I want to be able to see in a bigger area of the screen what I'm doing. Okay, so next I'm going to go and I'm going to hit Control A to highlight everything. I'm going to go up into Effects. I'm going to click on Equalization. And what do I have here? Let's flatten that. Okay, so I have this equalization plugin, and I'm set on a graphic EQ. Okay, I'm not on curves. You can have this this type of equalizer where you draw your own curves. I don't want to do that this time. I'm going to use the graphic EQ, and you can see I've got all these bands here that I talked about before. So let's change some of these bands. We'll get rid of the 20 Hertz completely. We'll get rid of the 25 Hertz completely. 31 will drop down most of the way. 40 will drop a bit. And so around 50 is when we start keeping things at about normal level. We've dropped out the bottom part. Okay, up around 80 to 100. I liked that a little bit, so I'm going to keep those where they are, but I'm going to drop the other stuff around those a tiny bit. Now, where's the next area that I had something? 150, 160, I guess I had a slight peak there. It doesn't look quite the same, but maybe I didn't write that down correctly. So we're going to keep all sorts of stuff below the normal, and then it was up around 4,000 that we had a slight peak, and then up around 11,000, so I guess halfway between these two, we had a slight peak, and the stuff up above, well, the 20 Hertz will take out completely, the 16 will drop a little bit. So I don't know, does that curve look sort of similar to what we had before? Hopefully yes. There is a preview function, it doesn't, I don't like the way it works, so anyway, let's assume that this rough approximate EQ curve matches what I did in Audition, and that's what I like. So let's apply it by hitting OK. Okay, now you see when that processed, the overall level of the waveform shrunk. Let me hit Control Z to undo. See, this is without the effect applied, without the equalization applied, and then if I go redo it, watch what's going to happen. The waveform is going to shrink a little bit. Okay, that's good. It goes back to where I said it's better to drop stuff out than to increase. If you ever apply equalization and your overall waveform increases a little bit, then take every part of your long curve or every one of your bands and drop them all a decibel or two, and that keeps it from having an overall increase in amplitude at any given point. Okay, let's just play a tiny bit of this, see if I like it. that sounds pretty good. I think from what I can tell, it sounds better than the original, and it certainly sounds better than the ones recorded from the cameras. So let's assume this is good. Now, I'm going to do two more things just quickly. Looking over here at the volume, you can see that the volume of the file jumps up and down as it plays from the 15-second mark up to the end of the song. Okay, if you look at the average peak, basically what I want to do here is some compression, sort of. Compression is something long and detailed I don't want to talk about in this video. It's getting long enough already. If you go to my DJ video on mastering and mixing in Ableton, and you go to around the 20-minute mark in it, I think. I'll post a note in YouTube. You can go to the section where I spend about 20 minutes explaining compression. That's worth watching because of this stuff. But for now, I'm going to show you a quick and dirty method of doing some sort of semi-compression, semi-limiting, semi-normalizing this file. Okay, so I'm going to pick the line straight across here where most of the peaks are hitting. Okay, it's kind of thickest around there, like say at minus 9, maybe, most of the, yeah. If we cut everything from above -9 and squished it back to be at -9, let's see what happens. The way to do that, Control A to highlight everything, go into Effect, we're going to go down to the hard limiter, okay, and we're going to leave the wet and residual at 1 and 0, and for decibel limit, I'm going to put in -9. And so what happens when I hit OK, it's going to take the entire file, any audio that is lower than -9 decibels is going to stay the way it is. Anything that is above -9 decibels is going to get flattened, so it ends up being at -9. So basically, instead of a bunch of peaks and valleys, there's going to be a point anytime where a peak was going above the -9 level, it's going to flatten off. It's not going to have that real peak. Okay, so let's watch the tips of all these peaks when I hit this at -9. Okay, now you can see that I've got a nice even line. Well, it's not an even line, but there is a line that you can infer by looking across the top of this. That line is at -9, and nothing goes above it. Okay, now what we're going to do, we've still got the whole thing highlighted. We're going to go into Effect, we're going into Amplify, and remember how right now nothing is any louder than -9? If we amplify the whole thing by, say, 8 decibels, then the peaks that we had before, which were touching -9, when you add 8 decibels of amplification, those peaks are now always going to touch -1. And you can see that Audacity knows this. It's showing you that nothing is going to be above -1. Okay, so let's hit OK. There. And what happened was we just amplified the entire waveform, and we have a lot of stuff that's close to the 0, which is close to full volume, but I don't ever like hitting full volume 0, so our peaks now are just a tiny bit, 1 decibel below that 0 mark. So what's the overall effect of this? Well, let's save this as, cancel that. We have to export, not save. Okay, we're going to export audio from Sony Recorder, EQ'd and amplified. Save. Save. Okay, so let's open the one audio from Sony Recorder before. And when you look at it this way, see how we've got a gap? We've got a lot of space kind of above the loudest part of the waveform but below 0. Yet, when you close that and go back into the one that we've played with, there's a lot less gap up here. We've performed some equalization, we've performed some amplification, but because we hard limited the file first before we amplified, we know that none of the parts of the file are ever going to be above the 0 decibel mark. The reason we don't want it above 0 decibels is because that's called clipping and it brings in distortion. Okay, so I already told you earlier in this video, I want you to study a bunch of stuff that you'd find on the internet, Wikipedia, all sorts of other tutorials, learn everything possible about equalization and about the audio frequency spectrum. And I also want you to look up clipping and find out why you don't want clipping, why you don't want distortion. In an audio environment, a little bit of distortion is good. You can hear distorted guitars. People, buy amps that can give you a distorted guitar sound on purpose. Analog distortion in small amounts sounds great to the human ear. Digital distortion, the kind of clipping that you get when you put the volume above 0 in a digital environment, sounds terrible. You don't want to get into it. Okay, so let's, now that we've got this adjusted file, the last thing that I'm going to do is I'm going to zoom in. So I've just highlighted the beginning of this. I'm going to go fit selection, and so now I've zoomed into this selection. We don't need this stuff at the beginning, so let's highlight that, erase it. Let's click on this button, fit project, and it kind of goes back out to the entire song. And once again, we're going to zoom in. Okay, and so we don't need this stuff at the end. And then finally what I'd like to do is, this is our final chord. It kind of fades out there. It doesn't fade out all the way to 0. So what I want to do is I'm going to highlight this section, and let's see if we can see. Look at that. Under effects there's a fade out. Click it. Okay, so we've got a nice fade there. So we've got our whole song here now. Let's once again export it, EQ'd and amplified, replace, okay. Okay, so the last thing that I want to do now is we've made some changes to our wave recorder's audio recording to try and make it sound better. And what I'm going to do is I'm going to import that into this video. I'm going to use the video from earlier where we filmed me playing the song, but instead of using the audio portion from that camera like we did before, I'm going to use the my video editor software. I'm going to bring in our fixed up audio. I'm going to overlay it perfectly over the corresponding audio from the camera, and so it's going to sound like, as I'm playing along, there's going to be a better audio file in the background instead of the real audio that we recorded. And so this is what the whole point was. What I'm saying is that you can, as a musician, you can record yourself on a camera playing along. You're recording your audio, recording the video, but you can fiddle with the audio portion to make it sound better, and then you can, if you know how to use video editing software, which I'm not getting into here, you can take that fixed up audio and marry it back to the video that you recorded, and so when that plays on YouTube, you upload it to YouTube, people are going to see you playing, they're going to hear it, but instead of being something where you've Yeah, I mean, this is basically better because this is not lip syncing. This is taking your actual audio that matches your video recording. Some people on YouTube, what they do is they record something, they create a really nice audio track, and then they'll just play that. They'll use a video camera and lip sync the entire thing, pretend that they're playing along with their audio file. Well, why bother doing that? That's ridiculous. That's like, you know, Milli Vanilli did that back in the early 90s. We can do better. We can take and match proper video to your audio. So that's the whole point of this. Okay? So if you want a comparison of the two versions, what you're going to hear in a minute is going to look like the stuff that I played a while ago in this tutorial, where it was the live recording. But if you flip back and forth, use YouTube, and jump back and forth on the timeline between the stuff that you're about to hear with the upgraded video versus the stuff that you heard with the live video, you're going to see that this upcoming stuff sounds a lot better. Okay? So that's all I want to talk about in this video. I've got all kinds of other audio recording videos that I want to come up with. We'll talk about doing effects. We won't necessarily use we won't necessarily focus on how to make your YouTube video sound better. We'll get into just doing audio projects where the whole point, you know, video is not involved. The whole point is to make a recording and to just produce a final audio file like an MP3 or a WAV file that you can give to your friends, stuff like that. So hopefully this stuff has this video. I mean, it's tedious. There's going to be parts where if you're a decent musician, you already know a lot of what I've talked about. But hopefully I've thrown in enough that a more beginner level musician has been able to learn some. I've given you some suggestions on stuff that you can learn outside of this video. And the next video that I do is probably going to go along a little bit quicker, and we'll get into some advanced stuff. So thank you for watching. Sorry if I'm a little bit verbose in this one, and enjoy. I seem to recognize your face, haunting, familiar, yet I can't seem to trace it. Cannot find the candle of thought to light your name. Lifetimes catching up with me. All those changes taking place, I wish I'd seen your place. No one's ever taken me. Hearts and thoughts, they fade away. Hearts and thoughts, they fade away. I swear I recognize your breath. Memories like fingerprints are slowly erasing me. You wouldn't call, 'cause I'm not my former. It's hard when you're stuck upon the shelf. I change by not changing at all. Small town predicts my fate. Perhaps that's what no one wants to see. I just wanna scream hello. My God, it's been so long. Never dreamed you'd return, but now here you are. here I am, hearts and thoughts they fade away. Hearts and thoughts they fade away. Hearts and thoughts they fade away. Hearts and thoughts they fade